Alright, so let's look at today's Leetcoding challenge question. It's called a binary tree maximum pass sum. It's very similar to the question from the second week, diameter of binary tree. So yeah, let's read the question. We have a non-empty binary tree. We need to find the maximum pass sum. The pass is defined as the sequence of nodes from some starting nodes to any nodes in the tree along the parent-child connection. The pass must contain at least one node and does not necessarily needs to go through the root. So the example here for the first example 1, 2, 3. So we start with this root node here, and along the parent-child connection to include all the 2 leaves. So the whole thing together, it's 2 from the left, 3 from the right, and the node itself is 1, so total is 6. That's the maximum. If we choose to drop any one of this, it's going to be smaller. The second example, we have a binary tree, a negative 10, 9, 20, 15, and 7. The biggest pass sum is this bold one, 15, 27, so that's add up to 42. So this one does not go through the root. So to solve this question, it's very similar to the diameter of binary tree question. Usually, the recursion is it's a little bit easier to solve to come up with a solution initially. And the way to think about it is that just imagine yourself as one of the intermediate node somewhere in the tree, like the node 20 here. What kind of information would you need from your children to make a rationale about the objectives, which is the maximum pass sum? So if I'm node 20, I will ask from my left, what kind of single parent node pass that I can get by connecting to you? What's the value that you can provide to me? And since there's only one node, it will provide me with 12 or 15. And I ask the same thing for the right children, and provide me with 7. And when I look at my own value, it's 20. So when I add all these 3 values together, it's 42. So as the best knowledge of myself at this position, I now say to the world that as far as I know, the best pass sum is 42. And what would I provide to my parent to help him to do the same kind of a rationale? For the node negative 10, you ask the left, you get 9. But when you ask me, 20, the node 20, what would I provide with him? It should be this 15, 20 sum together. I should provide 35 to the node negative 10, because that's the largest he can get by connecting with me as a right child. So obviously, if I'm negative, you should also just provide my parent with 0, because he can choose actually not to connect with me, so that I don't actually decrement the total's performance. So that's basically the recursive relationship, and we're just gonna define that and call this method recursively on both children and make a decision and provide that similar information back to my parent. So that's pretty much the solution. So let's code this up. So we have a initial global kind of variable to keep track of the maximum pass sum, which initially is negative infinity, as small as you can be, I'm gonna code a function called DFS, because when I ask my left child about the information, he will actually call his left child first. So it's kind of a depth first search thing. So if the node is null, it will return 0. Otherwise, I will ask my left what kind of stuff I can get from you. And I'm actually just gonna take the maximum of the 0 and this value. So if it's negative, I can choose not to take that pass from the left. For the right, it's the similar story. And for when I gather this information, as far as my knowledge, the maximum is gonna be. I can try to update this knowledge about the maximum to be left plus right plus my own value. So if any of this is negative, I can choose not to take them. So just greedily grab the positive values that I can add to form a higher pass sum, and compare that with the global kind of investor knowledge and update that. And in the end, I should return the my own value plus the whichever is higher, whichever child pass is higher. And I can actually just do a max 0 with this, so that the DFS call, when I call for my child, I don't have to take the max over there. Yeah, so I take a max so that I don't need to call max twice here. Okay, I think it should work. So for solving this problem, I'm just gonna call this DFS search on the root. And in the end, I just return this this thing. Let's see if it works. No. So reference the before assignment. Oh, okay. So this is the problem that the Python function is it's not, the scope doesn't work out very nice here. So I'm gonna just get a little sloppy and set this to self dot, so that so now it becomes a sort of like a reference rather than a primitive value. Okay. So this should work. Nope. Oh, okay. So many other problems today. Yeah. So that's it for the question. Yeah. So tree question is the general approach is just like this. Imagine you are some kind of intermediate node. Asking yourself what kind of information you need from the children to make a decision, and what kind of information you will need to provide to your parent to help him to do the same job. If you ask these two questions, you can figure out what to do here. Alright, so that's it for today.